Hello everyone. This question was asked in GATE 2020 Electronics and Communication paper as question number 46, and it pertains to electromagnetic theory. And in this question we basically are given a two-port network, and here we have a transformer with the turns ratio 2:1 given in this question. And here we are told that the reference impedance of 10 ohm is also given, right? And we are required to find the S21 parameter of this two-port network. Okay, so the NPTEL video course which we need to follow to understand the solution of this question is, the first one is the lecture number 9 and the second one is the lecture number 10 from NPTEL IIT Guwahati lecture series by Professor Ratnajit Bhattacharjee. Okay, the useful things that we need to have handy to solve this question is the equations of the S parameters. That's what we are asked to find out. So the first thing is S parameters. So how do you find S parameters? The first equation is B1 is equal to S11A1 plus S21, sorry, S12A2, and the second equation is B2 is equal to S21A1 plus S22A2. Out of this we are asked to find out S21. So how do you find S21? From this we will see that S21 is equal to B2 upon A1 when A2 is equal to 0. So this is what we are required to find. So to find S21 we need A1, B2 and A2 should be nullified. Okay, so we'll see what are these parameters, right? um Another thing which we need to know is, the second thing is, see, let's say if we have a network, we have this two-port network. This is a two-port network, say typical network. This is the second port, this is the first one, right? So if we have voltage here, this is V1, let's say this is plus, this is minus. Here also similarly we have, this is plus and minus. This voltage across these two terminals is V2. The current here going inside is, when we talk about a two-port network, it is always with respect to the network. Okay, we, whatever parameters we are defining, it is with respect to the network. So here this current will be going inside it. This is the incident current, let's say it's I1, and here this side it is I2. Okay, so this is just a convention. Even if we have a passive network here, say we have a resistor and nothing else, so basically the current, it will consume the current, right? So whatever the actual current is, I2 is minus of that current. Let's say here it's I, so I2 is equal to minus I. Okay, so yeah, so this is one thing. Now out of this what we can conclude is, the one thing is, oops, sorry, I haven't drawn the transformer, right? Let's say this is the transformer. Okay, this is the transformer. So let's say we have the positive notation on both the inductors. So with this circuit we will get V1 upon V2 is equal to, let's say we have the turns ratio as N1 is to N2. So this V1 is to V2, this ratio will turn out to be N1 upon N2. Okay, this is the first equation we get. Another equation which we can deduce from this circuit is I1 upon I2 is equal to minus of N2 upon N1. Okay, this is the second equation. Fine. Now one more thing which we need to keep a note of is, say this is our circuit, this one, right? So what is the resistance when we look from this side? Say, let's say that is Z2. And when we look into the secondary side through the primary side, let's say from here, it's Z1. So what is the relation between Z1 and Z2? Z1 upon Z2 is equal to N1 upon N2 the whole square. Okay, so this is the third thing which we need to keep a note of, right? um I think this is more or less, I think we've covered it. Now let's move on to the solution. So let's say we have this circuit. So what are the parameters now? We have to get a clarity on that. Let's say the incident voltage is A1, the reflected voltage is V1. This side the incident voltage is A2, and here the reflected voltage is B2, right? So if we approximate this circuit or two-port network by removing this, like we assume that we have removed it and we need to find out Z1 and Z2, what would they be? How would the circuit look like? And so according to our equation, Z1 upon Z2 is equal to N1 by N2 square. We are given it as 2 is to 1. So here this will be 2 by 1 square, that is 4. So this will give us that Z1 is equal to 4Z naught. Correct or not? Because Z2 is this side, right? Z2 is the impedance this side. Fine. And Z1 should be the impedance that we can realize when looking from this side, right? So Z1 is equal to 4Z naught. So this will be what we will get here after we simplify this circuit. This will be 4Z naught. Okay, this is some, say, hypothetical node here. And okay, to complete the circuit, let's draw the transformer here. So here we have this, because we have moved out this Z2 or Z0 from the secondary side and drawn the equivalent of that in the primary side, the A2 parameter is nullified now. Okay, and here we have B2. This is the same parameter A1, the incident voltage, and the because we have taken Z2 in the primary side, so the equivalent parameter of B2 in the primary side is, let's say it is B2 dash. Okay, so now we will see the relation amongst these parameters. We have, say, B2 dash upon A1, that is the ratio of the transmitted voltage upon the incident voltage, that is equal to N1 into Z1 upon N2 into, see, for A1, that is the incident voltage, the total impedance that it realizes would be Z1 plus Z2, because it is going to realize both these impedances. So here it is Z1 plus Z2. This will give out to be, this is 2 into 4 Z0 upon 1 into 4Z0 plus Z0. This is nothing but 1.6. Okay, so this is the ratio of B2 dash upon A1. So this is what we have got so far. Okay, but again, what is the relation between B2 dash and B2? B2 dash upon B2 is equal to N1 upon N2, right? This is 2 is to 1. And substituting this value here, what we will get? we will get that 1.6 is equal to 2b2 upon a1, and this will turn out to be b2 upon a1 is equal to zero point 0.8, or rather 0.80, rounded out up to 2 decimals. So this is what our solution should look like. This is S21, 0.80. Okay. Let's look at another way in which we can solve this question. Looks little bit tedious, right? So let's say now we saw that we had a transformer, right? This side we had a transformer with turns ratio 2 is to 1, right? So here it is. We were given a transformer with the turns ratio 2 is to 1, right? So what we can say is this is V1 plus minus, and let's say the coupling is positive, right? So let's say it's something like this. Okay, and similarly this side it's V2. Here it's I1 and here it's I2. Okay, so the two equations which we need to keep in mind is the first one being V1 by V2 is equal to N1 by N2, right? The second equation being I1 by I2 is equal to minus of N2 by N1, right? What this is 2 by 1, right? And what is this? This is minus 1 by 2. So what equations did we get? Let's pen them down. V1 is equal to 2V2 and I1 is equal to minus 1 by 2 I2. So this is one set of equations which we could derive from this. Now, instead of doing the tedious job, let us convert the S parameter from the T parameters that we can derive from this two-port network. Why we are taking the T parameters of this network is because it is way easier to find them, and then converting the T parameters into S parameters merely requires the knowledge of a few equations. What are those equations? Let's look at those equations. The first thing is S11 is equal to A plus B by Z naught minus CZ naught minus D upon A plus B by Z naught minus CZ plus CZ naught plus D. Let's call this whole expression as delta. Okay, so S, you'll see why I wrote that. S12 is equal to 2 AD minus BC upon delta. S21 is equal to 2 upon delta, and S22 is equal to minus A plus B by Z naught minus CZ naught plus D upon delta. So what we were asked to find is S21, right? So let's compare these equations with the equation of the T parameters. How do we find T parameters? We have another set of equations. We have V1 is equal to A V2 minus B I2, and I1 is equal to C V2 minus D I2, right? So A, B, C, D are the T parameters. Now compare these two equations. Simplest of the simple, we will get A is equal to 2, B is equal to 0, C is equal to 0, and D is equal to half. Now just simply substitute these values in this equation. We will get S21. Right away we can get it is equal to 2 upon A is 2 plus 0 upon Z naught minus 0 into Z naught plus D, which is half. So this is nothing but 2 upon 2.5, which is equal to 4 by 5, and this is nothing but 0.8. So directly we got our answer. S21 is equal to 0.8, or rather 0.80, rounded off to 2 decimal places as we were asked to find in the solution. So S21 is equal to 0.80 is our final answer, and you can see how quick we could get the solution simply by comparing the simplest of the equations. So here is the solution for this question. It is nothing but 0.80 for this S21 parameter. And to get more insights on this solution, refer to lecture 9 and 10 from NPTEL IIT Guwahati by Professor Ratnajit. Thank you.